Can everybody hear me? Yeah, good. Okay. I'm running a little bit late. I timed this for 19.5 minutes and then added a couple of slides, so I'm going to go a little bit quicker than I had in practice. So let's see here. This one, the talk is the need for speed, benchmarking Perl 6, but you know, it's not going to go to the next slide if I can't tell it to. It's really benchmarking the Perl family. It's not just Perl 6, it's NQP, it's Perl 5, so on and so forth. I absolutely love Perl 6, and I really want to use it at my day job, and not just in secret on little things. To do this, I really need Perl 6 to be production ready. If I'm going to sell it to my bosses, it needs to be production ready in some way, but you know, what exactly does that mean? Masek says we need features, we need documentation, we need concurrency, we need CPAN access, we need speed. My take on these is features. I agree with Masek on this. We mostly have them. There's a few bugs, there's a few missing things, but mostly we have the features we need. Documentation, we certainly have some, but we need more. Yes, well, but still. Concurrency, my personal use cases, sockets are fine for now. I work with RPCs all the time, both at my previous job and now it's the very RPC-based organization. So it's fine for me to not worry about the parallelism that Patrick was just talking about in the last class. I just need sockets for now. CPAN, working on that. My talk on Monday discussed some of the stuff that we were doing to try and get CPAN connected with Perl 6. The speed problem, that's the thing that's killing me. It's slow. Rikuo is slow. And that's a problem for me because I often have to deal with relatively big sets. So the speed problem. You know, to be sure, before I go on about this, there have been some big wins already. Patrick, Jonathan, heck, all of Perl 6, you guys have done great. You've made some big improvements, but there's clearly a long ways to go. So how fast is fast enough? How do we find the worst bottlenecks first so that we can knock those out and get, you know, the thing successively closer so that we don't have big gotchas that are slowing us down when we hit a particular thing? Well, my approach was pick Perl 5 as our gold standard. Everybody agrees that it's a fast scripting language or dynamic language. Let's pick that as our gold standard. We can do relatively good benchmarking against it because the operations of Perl 6 and Perl 5 are relatively parallel. It's easy to translate. So I picked some thresholds to beat. If it's no more than twice as slow as Perl 5, that's actually pretty good. You know, I think for a lot of the use cases, people would pick the programmer productivity over a few % faster if they could get more stuff done. Less than an order of magnitude, okay, that's okay. It's not great, but for some use cases, it's acceptable, so that's okay. But otherwise, we're just going to call it bad. And then we're going to benchmark it, benchmark the heck out of it. But there are several Perl 6 compilers, some of which have multiple backends. And we want to compare across the different languages, Perl 5, NQP, Perl 6. We want to compare against the different compilers. We want to compare different releases of the compilers, see if we're getting better, if we're regressing, where we're having problems, so on and so forth. And certainly we want to test against the backends. Is it faster on Parrot or JavaScript or JVM or MoreVM or what? So cloning copies for all these combinations would take a lot of bandwidth and time, let alone duplicated effort every time you want to keep the clones up to date. So every time you decided to fetch and you had all these different combinations, you'd be fetching a whole bunch of duplicate stuff. And if you just decided, okay, I can't do that, I'm going to have one clone for each compiler, well, that means it's kind of hard to do cross-version or cross-backend comparison all at once. Between each benchmark run, you'd have to clean up, check out a new version, build it from scratch, then try it again. Trust me, that takes a while, especially if your benchmark suite takes a while by itself, but a lot of our compilers take a long time to compile, and so that step is just onerous. So my solution was Perl 6 bench. It's plumbing. The time-all and analyze scripts are written in Perl 5 for speed and for consistent data, so that when I do timings, I know that problems with the script itself aren't causing the timing fluctuations. And the porcelain, the easy-to-use interface taken from the Git world, is bench. It's written in Perl 6 because it's fun. I want to write the porcelain in Perl 6. So it clones one mirror of each component across the network. You do bench setup. It does a whole bunch of cloning. This is where your major network traffic happens. Clones the heck out of things. You do a list of components, and you'll see that you end up with each component separately cloned by itself. And it does a mirror clone. So it's made now a clone of each one of these in a mirror state so that it's easy to make local clones. And in fact, that's exactly, I forgot. This is a quick digression. This is one of the added slides because a few people asked me this that hadn't gone to other Perl 6 talks. So what's what here? Of these components, several of them are in the Rikuo stack. Rikuo is Perl 6, and I'm going to say it's Perl 6 on NQP because that's kind of where we want to be anyway. NQP, the one that I just listed as NQP, is the original. It's not quite Perl on Parrot. And then, of course, there's the JavaScript backend, the JVM backend. There's then underneath the NQP layers, there's Parrot and more VM as active VMs. For the JVM, I'm actually just using the system VM for these tests because it's pain. And then we've got some of the other compilers. We've got Nietzsche, which is Perl 6 on mono.net, Perlito, which is both Perl 5 and 6 on Perl 5 and JS and etc. And then, of course, Perl 5, which is actually the standard Perl 5. I've actually cloned the master repo. OK. So it makes local clones as needed. You just ask it to extract, and you say, OK, from the Perl 5, I want to pull this tag. From NQP, I want to pull this tag. From Rikuo, I want to pull this branch. It extracts them out. If I list my checkouts, I actually get more than just that. But you'll notice that the extra ones are ones that are just named the same thing as the component. And what this basically is a checkout of the head of whatever is the default branch. So you'll notice down here, Rikuo num and Rikuo are listed as the same thing because, in fact, that's the default branch on Rikuo. That way you always can see what the current head revision is, and you can always compare any version that you've checked out against what's the current head. So it knows how to keep all this stuff up to date and with a single command by updating the mirror first, then the non-tag checkouts. Because there's no point in updating the tags unless you've got problems with people moving tags around the repo, which is just bad. So in here, you do a bench fetch. Let's say it starts on Nietzsche. It goes fetch. It goes, OK, here's the mirror, the .git. It fetches data into the mirror. It does the Nietzsche fetch and v24, which is a tag that I'd pulled out on my local system. And then it does the pull. It does the actual merge if necessary. And the only one here that wasn't a tag was the head revision. And in this case, it was already up to date because I'd just done this recently. But then it goes on and continues with NQP and so on and so forth. This will take a few minutes because it's only doing deltas across the network to the clones. And then it's doing local checkouts. And those are really fast to fetch new stuff. OK, so you can build each of these multiple checkouts in sequence. So you don't have to sit there and manually do each one yourself. You can say, OK, I'm going to build everything that I've checked out of NQP, everything out of NQP JVM. And for Perl 5, I want to do this tag. Rikuo, I want to do these two tags in this branch. Go have a fine meal. This will take a while because it does them in sequence. And there's a reason it does them in sequence. It's because some of these have really large build requirements. The memory that's used to build them is very large. You would OOM yourself if you tried to do like 3 builds of Rikuo at once and you didn't have a monster box. So it does these in sequence. Make sure that it's using the minimum memory requirements. And then you just wait for a while, have fun, and yes, it will prevent Rikuo NQP and NQP-CC. That's the cross-compiler. That's the current version of NQP that we have to use for more VM because it's not bootstrapped yet. Each of them are kept from cloning their own dependencies because in their build cycle, they want to do like gen parrot or something. It wants to pull parrot and build that as well. It wants to make a clone, but during the thing, after we do our cleanup to prepare for the build, we immediately do a local clone forcing it to take local clones of our master mirror repos and then lets it gen parrot and so on and so forth. So once you've done a setup or a fetch if it's been a while since the last time, the thing can stay completely off the network. It will do all of its stuff locally, with the one exception of Nietzsche, which wants to pull down a tarball when you do different tags. It needs an older version of itself to do a newer version, and we found that there were so many differences there that it wouldn't have saved us network bandwidth. Okay, so now that you've got all this stuff built, how do you go about benchmarking? Well, you gather some timings. If you just say bench time, it will time every compiler you've built against every test. If you say only particular ones, you can say, okay, I want only these checkouts, only particular compiler modes, or I want these things tested only against these two tests, or any number of them. You just say certain tests and you can go on with it. When you want to analyze the results that you've just created from the timing passes, you can compare them, just bench compare, and it will ignore startup and compile time by default. You can turn this off if you want to see the effects that compile time or startup time has on the overall performance comparisons, but by default it'll ignore them because most of the time we're actually worried about the runtime performance of these. And it'll just output the results to screen. It's just text. So you can say, okay, I want to only compare timings from just this compiler. For example, I want to only see the different builds that I've done for Rikuo. I want to see how it's changing over time and if it's regressed or anything like that. If you don't like the colors, because by default it's colorized, you can just turn that off. If you want to take all the timing data, do a comparison, and then merge that information into a single JSON file. All the timing data is saved as JSON files, but if you want to have it as a single file, you can send somebody, so you can say, here's my timings, and here's the comparison I did. Here, take a look at it. If you just say that you're going to output into a .json file, it recognizes that and goes, instead of printing the screen, print to the merged JSON file, and now you've got something you can email somebody. Okay. You can also output to HTML as a table, similar format to the screen format, but producing HTML. If you say the out file is HTML, there you go. And here I've said I'm comparing only particular timing runs. Now here's where it gets interesting. You can actually plot them as well. If you say that the output format is HTML plot, then it will produce an HTML file that uses the JQplot library to produce a whole bunch of plots that tell you how certain benchmarks scale as you add more load. As you say, like, do more iterations of this, or do a deeper man or boy test, or something like that, it will then produce a plot of the scaled output. For tests that can't scale, it will just produce a bar chart that shows the comparison between each of them. So here's a good sample. This is the while array set. So it's doing a while loop and setting entries in an array. And it's just doing this and seeing, like, okay, as you ask it to produce more iterations of the while loop in a single test run, how does the iterations per second that are measured turn out? And you can see some noise on the left-hand side as there's little timing variations, and because I'm subtracting out so many different things, the startup time and the compile time, sometimes there's little glitches where it will end up being a little bit off. But mostly, you get some noisy stuff, and then it settles down, and you start to see patterns here. Well, what kind of patterns are we seeing? First of all, I should tell you this is a log plot. Okay, so if you look at this thing, you've got a log of the work to be done here and a log of the results here. So when you get to a happy place, it's going to be mostly a horizontal line across here, same throughput for increasing load. Okay, so the ascending portion, as the lines are going up on the left-hand side of the graph, is when overhead or warm-up that I could not subtract out is still dominating. The JVM is famous for this. The JVM has a period in which it is warming up its JIT, and so there is a period where you'll get a domination of that warm-up effect. The horizontal portion, as I said, is about as fast as it's going to get. Hopefully you'll get nice, steady, thorough throughput above a certain load. And the descending portion is when you have some problems scaling up. So here you see that for this particular test, something was happening up here that eventually it would reach a peak and it would start to slow down. And the rightmost point that you see on these graphs, each one of these lines has a rightmost point. That's when it ran over the time limit, because for scalable tests, it determines a time limit and says, I'm going to keep offering more load to it until it takes more than, say, 5 seconds to complete the test. By the way, those 5 seconds already have the startup and compile time subtracted, so you don't need to worry that something that slows up really, that starts up really slowly is going to affect that. Okay, so here's a nearly ideal plot, the WhileEmpty plot. So this thing just is an empty while loop. It's just doing an iteration counter. And here you can see that, once you get past the noise and the ascending portion, here's what I was talking about of the slow warm-up of the JVM. Past this point, it gets a pretty steady state. You have steady states on all of them, all the way across. Here's the same test with native types, and I'm going to flick back and forth so you can see the difference. You'll see that one of these jumped up and one of them is missing. Well, that's because Nietzsche doesn't support the referring to the native types here, but JVM really loves it when loop iteration variables are native types. It gets fully as fast as Perl 5. So here's a case of a mild weakness that's in Perl 5. It slightly slows down. Okay, so, and since these are a doubling in between each of these, if you look at this, it's maybe 3 or 4 times slower than its peak value. Most of the other ones hit a straight or they get pretty close to it, but there's a slight slowdown in Perl 5.
Is the size of the hash increasing during that?
Yes, I believe so. Okay, so here's a case where the test scale kind of gets off kilter because this is a nonlinear test. You see that it says visit 2D indices, so it's a nested while loop and scaling both the inner loop and the outer loop. And so you end up with something where you get diagonal lines down from the log-log plot effect, but you can still see the difference between them based on where they kind of are in the vertical ranking here. And so this is a particular kind of test that scales like this. The man or boy test does the same thing because as you increase the k parameter for the man or boy test, it gets rapidly more work, and you see it scale down the same way. Okay, so far these have all been micro benchmarks. The code is kept as close as possible to an exact translation between the languages. That's relatively easy at the micro benchmark scale. But what about longer or more idiomatic code? Well, I only have time to show you one of these, but we're going to go with this one, RC ForestFire. It's a simple 2D cellular automaton. It simulates a growing forest with occasional forest fires. I know it's a little hard to see on this projectors, but there's your forest fire, and here's another one down here. So here's the differences, and I'll answer your concern in a minute.
I'm not going to say we're already made my concerns now.
Okay. So here we go. Here are the differences for these. This is Perl, the current Perl 5, the May version, and here's NQP JVM doing it, and the standard NQP, and then Nietzsche and Rikuo down here. And these things, this one is the frames requested per run, how many cycles of the cellular automaton, and this is how many frames per second we're getting out of it. Perl 5, of course, the fastest. I actually checked on here. If you do these plots live rather than on the projected version, you can just roll over any data point and you can see its measured value and the comparison against the fastest. And you see here that in this test, NQP JVM is about 2.5 times slower at best. This is not with native types. I'm sorry, I did not have time to make a version of this test with native types. NQP is about 8 times slower at its best mark, Nietzsche 45, and Rikuo slower than that. So I want to use Perl 6. I want to use the full Perl 6. I don't want to be using NQP all day to do my work. I want to use the full Rikuo. If it's slow, if it's the one at the bottom of the chart, why am I so happy? Okay? And it's because NQP JVM is already considerably faster than NQP Parrot, and in some cases that I've tested, and that was just an example in one of those previous slides, it's as fast as Perl 5. Sometimes actually gets a little bit faster. It hasn't reached the make it fast stage, okay? It's still in the make it work, make everything, like fill in the gaps that we need for Rikuo. It hasn't been in the Jonathan goes crazy mode, okay? And I think that bodes very well for Rikuo's performance in the coming months. The fact that Rikuo sits on top of NQP, and NQP in some cases can be as fast as Perl 5, I see that as being really good news. So, clearly, yes, there's a long way to go to get everything pulled up, but now we know where to go, we can measure our progress, and pull requests are welcome. If you want to add more tests, if you say, hey, I found this particularly slow operation and I would like to add it to the benchmark suite, please do, okay? Under JAFB Perl 6 bench on GitHub, talk to me on hash Perl 6, and any questions? Yes?
Do you have a graph of for performance as a function of commit date, or was that in the part that I missed?
No, I don't. I set it up so that we could produce those, but I haven't produced any of those yet. Partially, that's a matter of Rikuo that before, like during the benchmarking cycle over the last 6 months as I was slowly building this, we discovered some things that Rikuo was doing particularly badly enough that it couldn't finish basic tests just from like it slowed down too much. Those were fixed. So now recent stuff is pretty safe to benchmark. We have no problems there, but we can't go very far back before we run into there's parts of the test suite we can't complete. But going forward, I definitely want to be able to produce plots of a single compiler over time. And in fact, if you just did multiple checkouts and built them and compared them, that's pretty much what you get. Anybody else? Yes?
Would it make sense to add Rikuo star to the list of?
Question is, would it make sense to add Rikuo star? I suppose it might be useful to see at the various tags how Rikuo is doing, but I think at this point it's making more sense for us to just see Rikuo at each monthly release cycle, because really they're not changing the compiler when they make Rikuo star. It's still Rikuo underneath, and I'm not yet testing stuff in standard libraries. I'm absolutely considering doing that, but I haven't yet gotten to that stage. Any other questions? Great. Thank you guys very much. Oh, sure.
What was his concern that you didn't say about?
His concern is that I wasn't showing Rikuo in its best light on the RC ForestFire because I had, when I did idiomatic in my mind, which he said was stressing different data structures and different methods of doing things than were in Perl 5, and that wasn't an entirely fair comparison, and also that I didn't have time to put in the native types into that test. And when I was thinking about the final thing this morning, when I was working on the slide deck, the decision that I came to is my feeling at the end of this is one of hope, that there's so much forward there. And it doesn't matter that, maybe Rikuo could have been twice as high as it was. To me, that's not the important part. The important part is that the infrastructure underneath Rikuo is doing quite well. And now we just need to bring it up to the level of NQP, and I think we'll be in a great, great place. Does that answer your question?
Yes.
Yeah, okay.
Can I add my other comment there?
Sure, go for it.
The ForestFire benchmark, which Rikuo does badly out. But I should also preface this with, I found the benchmarking suite. He gave me an advanced copy of the thing and stuff. It's incredibly useful. We will make such good use of this in developing Rikuo. The ForestFire implementation for Perl 6 is an object-oriented one, and the one in Perl 5 is done in subs. What would it look like if it was done in Perl 5 in loops? Then what would the performance be like? That is a somewhat more apt comparison for somebody who plans to do object-oriented programming, which is one of the reasons why you would go with Perl 6. In all of the microbenchmarks, you're testing Perl 5 in its best light, and Perl 6 in its worst light, because Perl 6 has all of the overhead of doing objects. But it's really more apt if you're talking about application programming. Just compare Perl 5 and object-oriented environment. Then see how slow, and I can see that there are fields very slow. That would be a more useful test.
But again, that will change.
Yeah.
Yeah, I mean.
I have no doubt. It's so easy to add benchmarks. You just kind of test on it. It's like really rough.
It sounds like the ideal there would be to have non-OO and OO variants in both languages.
Correct.
Yes, and that's exactly what we plan.
Variant for just to test it for Rikuo and ran it there. And I was surprised it wasn't that much faster. But
it has been observed that one of Perl's weaknesses is function all over it.
Yes.
Yes. Sorry, I should probably take this off and